Welcome everyone to another edition of ALN Thursday at 3. This week we are welcoming back Keith Gipson and Danielle Radden from facil.ai. They've got some very good stories to tell and some details to tell about their AI application on top of smart assets. We'll be with them in just a second, but first we like to say thank you to our patron members, Jacobs, Mantech, Onuma, ABS Quality Evaluations, and CGI, and all of our organizational members, which we're growing with this ALN Pilot Project Network. Please reach out to me. I'll put my email in the chat. It's a way to demonstrate capabilities of proven but advanced processes and tools that owners might not even know are available. And we're finding a lot of good traction that this is an effective way for a nonprofit organization to help advance asset management in all the industries. So please reach out for that. And let's get into it. So Keith Gipson, thanks for joining again. And
Thank
Danielle, you can come on. And some very timely news about facil.ai. Keith, you want to tell us what's happened?
Yes, thank you, Mike, and I'm very pleased to share with ALN and your viewership. We're very excited about. We got a great industry award, and I think it was really a happy moment for us. I kind of like maybe Danielle, you might want to elaborate, introduce yourself and elaborate. But yeah, it was a very happy moment for us winning that Digi Award, as well as our customer Kenny Seaton from CSUDH winning Most Intelligent University.
Yeah, and I think I am sharing the screen of the official award picture of Best AI Tech Innovation.
Yes, you are.
Perfect. Yeah, and then our customer Kenny Seaton at Cal State Dominguez Hills won for Most Intelligent Campus. So I can switch over and grab that. We have an announcement on our website, so that's been kind of fun to share from there. And let me see if I can pull that over onto this screen. Yeah,
Yes.
so there's Kenny in his Kenergy t-shirt, or his Kenergy button up. He said, "I don't want anything to reflect Barbie. I'm the Kenergy that reflects real energy."
That's right.
So he's got all of the energy shirts.
So can you tell us about the two awards? Keith,
Yeah.
why don't you talk about yours?
Yeah, so I'll talk about ours, Danielle. Maybe you might want to talk a little bit about our affiliation with Ken and that sort of thing. But yeah, we got Best AI Tech Innovation for Intelligent Buildings, which was a huge, I mean, obviously like AI is really big, a big topic of discussion. And really, I really think that this was a starting point of where people are starting to realize that AI is a thing. It's not going away. It's not a fad. I mean, AI has arrived. Honestly, we didn't think we were going to get the awards. Honestly, I mean, I was so happy and just surprised that we got it. And we beat out some great companies, other companies that were more around, dashboards, fault detection, and that sort of thing. So, to get the best AI technology for non-dashboard, non-FDDO, other category was really great. I mean, so advanced supervisory control, has arrived, and I think this was a major win for us, and especially we made it even much more better, just winning along with our customer Kenny.
Okay, so let's break this down a bit. So Realcomm is a very big, significant conference. They have conferences. This was, I believe, their main conference. Thousands of people are attending. And so we're going to be doing that and bringing information about your technology to the market. Were you exhibiting?
Yes, we had a booth there. We had some partners in our booth talking about AI and going to market, talking to customers. You know, this is pretty much like the Oscars for our industry. So again, just extremely humbled and just grateful that to get this recognition. And like I said, it was just that much more sweeter with having Kenny, our partner, really our customer, and really partner along with us to share the spotlight.
Okay, so this was an award for specifically, I see chiller optimization.
Yes.
And you were talking about some of the details. So can you explain a little bit about this so that others might want to reach out to you and find out?
Sure. So I think there's a lot of different AI categories or flavors out there. Our specific area, we're under the guise of a prescriptive AI. So there's, you know, there's a generative AI like ChatGPT, like that's what the, you know, G stands for, and GPT is generative pre-trained. So there's a model that the system gets trained on, typically by humans. So humans make the model what they think is right, and then they teach the AI. And then there's the next one is predictive AI, which is like you know, TensorFlow, model predictive control, like, you know, predictive is in the name, like MPC. And again, that's model driven. That's okay. Our system is model driven as well. The only difference between us is that and other technologies out there in the building optimization industry is that other people are disconnecting the chiller so from the model. And so the chiller kind of drives the chiller information, and telemetry kind of goes into the simulation, and then the AI interacts with the simulation instead of the real thing. We just kind of cut that out the loop, and our AI continuously experiments and teaches itself, builds its own model, and learns how to run the chiller better than any human being could ever hope to. So that's the big, I call it more like it's not a digital twin, it's more like a Siamese twin, I always say. So we're direct, we don't need to simulate what the chiller's doing. We're getting the real-time live telemetry coming off the chiller by virtue of, and other equipment by virtue of our, you know, plug and play independent data layer, our software gateways, no hardware needed. So I think it's that kind of 1-2 punch that we're not simulating. We're actually, our AI experiments directly on the equipment. So I think that's a huge departure from the norm, because a lot of companies, they'll even try to instill a little bit of FUD, you know, fear, uncertainty, and doubt. It's like, you know, you don't want to be reckless. You know, like those facil folks, you know, they run, their AI runs right on the piece of equipment. It's like, well, yeah, we have decades of experience doing this stuff. I always say, like, I was the same guy probably that programmed the Commodore 64 hanging on the wall 20 years ago, you know, for your central plant. So I got better tools right now. I got this cloud-based, you know, super computing capability and artificial intelligence. So yeah, this is better together. This is PID loop plus AI and machine learning.
Okay, so I think you've made the case for why you won the award right there.
Yeah.
Excellent.
And it's our results, right? I mean, 48% energy efficiency gain is just really, I mean, candidly, it's just unheard of in our industry. Like, we struggle to do 5 to 15% efficiency gain. Yeah, 48% is just, you know, it just knocks it out of the park.
I'm spelling that out in the chat just to verify. That's 48% efficiency gain. That's incredible. Can you explain how some of that was achieved?
Yes. So really, I think the first agent that we developed for the central plant is really the condenser water reset agent or approach. You know, so at the business end of it, it's all about heat rejection. Like, HVAC is all about moving heat from one place to another. So it captures. It's like a transportation system, like a conveyor belt, I always say. So we're removing the heat from the space, turning it into water energy, putting it in the chiller, then that gets passed over to the condenser loop, and then it gets rejected at the cooling tower. And really what you're trying to do is maximize the psychometric function, that affinity, matching the condenser water exactly, precisely to the outside air wet bulb temperature, to maximize that affinity and that transfer of heat out of the loop. And so it's not about trying to do less work or locking out stuff and making the fans not go on the cooling tower. Like AI is not biased like that. It actually might run the fans more, or it's not it's about achieving precision and not just sheer reduction. One of the benefits of our system is that it turns a 1,000-ton rated chiller into a 1,300 or 1,400-ton machine. So it's not about robbing Peter to pay Paul or cheating or doing anything like humans do. It's letting the AI decide, build its own model, find out what the ground truth is. In AI, that's called ground truth labeling or training. This is more inference learning in real time, so that the AI is always constantly learning, trying new stuff. And it does that every 5 minutes. It figures out if it can get better and better and better. So we just smashed through. You can see the standard on there according to ASHRAE 90.1. A standard, an average chiller is at right about 0.7 kW per ton. Like that's it. Like for years, decades, if you were at 0.7, like you've arrived. Like you can't get better than that. That's the average. That's the ASHRAE standard. Good is considered 0.65 or below. And then 0.45 is the absolute, best you could possibly do, best in quotes, because we're actually even achieving more than that. So at the chiller, we're getting below 0.3 kW per ton. That 0.45 average that we're doing, 0.45 to 0.5, is overall central plant efficiency. So that includes the chiller. Everybody in this industry has been trying to satisfy the chiller, and the chiller is the most efficient part of the puzzle. So instead of trying to optimize, make more efficient the most efficient piece in the puzzle, maybe we should look at the other stuff that's less efficient, like the cooling towers and the fans. And there's this crossover point where you're going to lean more on the cooling tower equipment versus the chiller. And the AI is able to identify that sweet spot 24/7, 365, no other, like a human could never hope to do.
Okay, so that is excellent engineering information, and I'm starting to see, and your numbers are lining up with that 48%. It becomes very clear. But let's talk to the leaders. Let's talk to the people running the companies who really aren't focused on the engineering side. What does it mean to improve? Did you say 100-ton chiller to 1,300-ton chiller?
1,000 ton to 1,300. Yes, 1,000-ton rated chiller.
What does that mean in dollars and cents in terms of initial costs, or then increasing value from your existing?
Yeah.
Maybe it's a monthly savings or something like that.
Great question. What it does is it pushes off the inevitable, new construction, which is a CapEx expense. Think about it. No one could have foreseen the dramatic increase in prices and/or grid, load on the grid. So I'll give you an example. One of our other customers is kind of like the big brother campus of Cal State Dominguez Hills, and that's University of Southern California, USC. So same crimson and gold. I guess CSUDH used to be a satellite college. I didn't even know that, but
Oh, wow.
Yeah, they're like a smaller version. They were a satellite campus for USC back in the day. But yeah, USC is a great example. They've got like 12 central plants, and so we're engaged with USC. They're an old friend of mine. Used to work there decades ago as a technician for Honeywell, and there's a lot of family, like just friendly, just association there. So
Yep.
we're starting the install next week at USC in one of their central plants. We're going to start, baby steps. We're going to start it off. But what that means is they came to us not because that they wanted to save energy. Yes, they want to save energy, but they're running out of capacity of their end all beat all. They were installed a big central plant, and they're like, we're set for 12 years. Nope. They started adding buildings and they've added I think it's 1 million square feet or more of space, and that central plant cannot absorb that. So they have a capacity problem. And so think about it, they won't have to spend millions of dollars in new construction on another central plant in downtime. Through the use of AI, we're going to turn every single chiller and get 30 to 50% additional capacity from the same existing machine.
Okay, that we can right now, because that information alone is worth this entire hour. But I was joking, we're not going to stop because there's more examples of that type of efficiencies from your use of AI. Is there anything else about the chiller plant efficiency that you want to relate?
Yeah, absolutely. So AI is actually driving the chiller usage in data centers, large data centers. We just got another customer of ours, and it's actually the Waymo data center. So I mean, talk about a mission critical customer. So people talk about the mission criticality of a central plant. Yeah, we just landed the Waymo data center here in LA. So you can have autonomous self-driving cars, like that's pretty mission critical. So and so is the cooling. So yeah, it's all about being more precise. I think there's this attitude that the AI is going to somehow go berserk and hallucinate and stuff like that. That's not how it works. You know, it's not. It's closely defined. It's prescriptive. We've got guardrails in there. The AI is not going to go rogue. Because always a continuous reward and punishment process. So if it starts going away and it's making small steps, it's not doing anything outrageous. It's just not throwing stuff out there because, you know, we're chiller and central plant experts. So we taught our AI where to start and how to go along. But we didn't teach it what the settings were. We taught it how to find the settings. That's an important distinction. So to summarize, it kind of makes sense. If you're getting a 50% efficiency increase, then you would think that you would have a 50% more capacity for using the same electricity, right? I mean, why haven't we seen this in practice and other HVAC and energy conservation measures? It's because we're cheating. We're locking out motors, we're raising set points to the edge of comfort, ragged edge of comfort. We're making people suffer in terrible conditions in the summer because we set the unoccupied set point from 75 degrees or 76 up to 85 degrees. You know, it's like the doctor, if one pill is good, two is better. No, we're trying to get back to the way building control systems were designed. That's why thermostats come out the box set at 72 degrees. So I call this actually the DR effect, where, you know, what do you do to save energy during a DR event? You raise the set point. This is not an energy conservation move. You're suffering. You're trying to remove constraint, and it's a prescribed event where you're getting compensated for your suffering, right? You turn off every light bulb in your retail store, every other fixture during a DR event. Oh, so let's just do that all the time. No, your product is not illuminated. I don't know why we just lose our mind when we talk about energy savings. We confuse prescribed temporary events with a long-term strategy, and we never should have done it.
All right, so this is a key point, that asset management and literally asset leadership started a whole new phase in 2014 with the publishing of the ISO 55000 series of standards. And that changed the definition of an asset from something that had a depreciated value to anything. Asset management is anything, or an asset is anything that gives value to an organization. And what you're doing is extracting more value from the asset. And that's why I'm so excited that you've joined and are sharing this information with the leaders who are watching this. So thank you for that.
I think there's a question from the attendees. I think Danielle, you might want to jump in and address that question, if you don't mind.
Yeah, there was a question about how does facil.ai respond to end user customer requests. So the example is in a restaurant that's too cold, there's no real response. It's just that the customers suffer, so the occupants are cold, and there's nothing that they can really do. So the nice thing about the AI is that we're looking at actual internal temperatures. We're not relying on a set point, because a set point is just a number. Intrinsically, your thermostat doesn't know if it has hit 72 degrees. It needs some sort of feedback. It needs a sensor. So we're using data from those sensors, and we're not just saying run the HVAC until we arbitrarily hit some random number. We're using actual data. So what ends up happening is we can attain a more precise level of control because every 5 minutes we're running a feedback loop that says, is this the temperature we want? Yes or no. If it is, then we don't do anything. If it's not, then we have an AI model that can make an adjustment to better accommodate the end users or the end customers. So what ends up happening is we have fewer comfort complaints, is what we would call them. And because the AI every 5 minutes is effectively acting as that end user, that occupant, and saying, oh, I'm cold or I'm hot, because it's a real end value. It's not just an arbitrary set point. Does that answer your question? Hopefully that does.
Yes, yes, we'll keep the,
Okay.
yes, he says.
Yeah,
Excellent.
it's that cannot be underestimated as well. You know, Danielle, we talk about precision all the time. Another one of our customers is a large. They don't want us saying it publicly, but it's a large museum in Los Angeles County. I mean, they've got, what's the cost of those assets? Like, they're priceless, right? They got, you know, Picasso's hanging on the wall. It's
Yeah.
not even about saving energy there. It's about preserving these priceless, literally priceless artifacts. They're struggling like everyone else with humidity control. So how are you gonna do that? And you need to add capacity to the equation. And the chiller needs, it starts at the chiller, which produces the colder water needed to wring that moisture out at the coil on the air handling unit. So we're being brought in not to save energy. That's not it. We have priceless works of art here. So and they've been struggling with this humidity issue for like literally 40 years. And they brought in all kind of consultants. They're putting in bigger units. It's just, you need to bring a level of increased capacity and precision to the control. I'm a car guy and I like analogies. So it's like my dad had this old 1972 Chevy Econoline van. And like really, it had so much play in it. So you didn't reach, if you had your hands like this and you turned it this much, like it would still be going straight. So you had to play in it, and then you had to compensate for it. You had to turn it a little bit more to start. So your action was like way down here, and nothing happened in between here. So that's similar to a maybe silly analogy, but that's how building control systems work. Like, they're not precise, they're not accurate. It's literally called it's a 4 to 6 degree dead band. Why is it called a dead band? Because that's the slosh factor. So you set your set point of 72, 72 equals 78 to 68. And everywhere in between. So you have zero precision. It's just sloshing back and forth. And if you're in a cooling scenario, it's always gonna butt up against the high set point. So yeah, you set it at 72. And then if you set it at 72, you're lucky if you can control down to 75 or 76. Imagine what these folks are doing, and there's almost this perverse incentive. It's like plausible deniability. Like I only set it to 76. Come on, you know that equals 80 to 82 degrees in your stores. So, you know, come on, stop it. Like you really know, it's like wink, wink. You know, I'm trying to keep the set points there. It doesn't matter what the set point is at. It matters what's really going on in reality. So
You cut through it really good, Keith, and you emphasize once again the asset leadership perspective on this. It's about the value of the assets and maintaining the value of the assets. And we started an ALN Art Asset Leadership Board, and we didn't even think of the museums. We had someone from University Health, which is an institution that has $10 million in art assets that they need to maintain and keep up, and the importance of that. But I think you're going to help us go into the art museum market to get those leaders to understand.
Yeah, healthcare is another. I mean, you get hospital-acquired infections happen at an alarming rate. So I mean, literally, you're saving lives. Like I'm not trying to be overly dramatic or melodramatic, but I mean,
not at all.
Seriously, you got a burn unit and you got to control the humidity and the temperature precisely. I mean, you're gonna kill somebody. Like, imagine some monitoring company trying to save you energy at a hospital. Like, they're gonna literally kill people. And I mean, it's serious. Like
Oh
we
my
got to
goodness.
get out of this short-sighted mentality of saving energy, saving nickels and dimes at all costs. What does it cost you to have a rise in hospital-acquired infections, or people not wanting to linger in your store to shop because they're so uncomfortable? They're freezing in the grocery store, they're hot in the discount store. And yeah, I'm gonna kind of, that's revenue walking out the door. So you're exactly right. I love that we're on the asset leadership network, because that's what our building control systems and controls should be doing. They should be enhancing the asset, not degrading it.
Yes. Well, there are so many topics that I want to address with you, but Danielle, will you talk about the other award that your client won, Railcom?
Of course, yeah. So Kenny Seaton is the plant manager at CSU Dominguez Hills, and he specifically was asked to come to Realcomm by the organizers. They had a quick meeting, and I think the organizers were blown away with what he is doing. His philosophy, and I don't know if he's sitting in the room over there, Kenny or Keith, but so he's going to hear all the bragging. His philosophy is if better is possible, good is not enough. And I love Kenny for this because ultimately what he's built his entire life around is this idea that he's not going to accept something just because it's gotten him through, just because it's good enough. He's always going to push the level, he's always going to push the line. And if it seems impossible, then you just take it one step at a time. I mean, it's the old joke of how do you eat an elephant? Well, you eat it one bite at a time. And so that's kind of how he's approached his entire progress towards his plant. And actually, I have another slide that I can share. I stopped sharing my screen, but I'll share it again.
Thank you. And if
Hmm.
Kenny does want to join, Keith, he's more than welcome to sit in and, just slide next to you and say anything.
So I've got this slide. So this is his plant energy from 2020 to 2025. And I like this slide for personal reasons because we actually had to extract the data during the facile operation phase because it was skewing all of the results. It was so efficient when we started implementing the AI. But overall, Kenny is making waves in the industry because he is able to track exactly what he's saved for the past 10, 15 years. He's reduced his greenhouse gas emissions by 70%,
Wow.
which, I mean, in our industry, that's impossible. But he's doing it because he's doing it one step at a time. Because every time he gets to something that's good enough, he says, no, better is possible, and this isn't enough anymore. So he's
So
always pushing the limit.
So I hope Kenny's listening because the last item in the to-do list of ISO 55001 is continual improvement. You've just done things better than you've ever done before, but in order to get certified, you've got to show or at least be talking about what you're going to be doing better next.
Mm-hmm. Yep. So that's kind of the award that he won. And we are very extremely proud of this because the other candidates that were up on the panel for this award were, well, what was it? I don't remember, Keith. It was oh, you're on mute.
Yeah, it was
Was it?
Stanford
That's
University
right.
and UC Davis. Both
That's
were
right.
known leaders in that quadrant. And then I'm gonna say I don't want to go out of my way to mention our competitors, but I mean they were very well funded companies, even some funded by multi-billion dollar controls company. And here's this startup, this small startup that's self-funding and family and friends that were able to achieve that. So I mean it's a badge of honor for us, because we
Mhm.
weren't expected. Neither one of us or Kenny were expected to win out to get such a prestigious award. So we're just grateful that we're recognized in this manner.
Right. It really is kind of the underdog story.
Yeah.
I mean, Kenny tells a story about how he didn't have a budget he wanted some smart energy valves. And he said, I don't have a budget for this. So instead of trying to make it a capital expense and get it approved and push it over the line, he just, at the end of every month, he says, all right, I had $400, so I bought one. And he did that every month until all of a sudden he had these valves and the sensors all over his campus. And, you know, it took him 16 months, but he did it because he took it one step at a time. So
That's
it's
excellent.
very much an underdog story.
Well, it's a working smarter story.
Yeah, exactly.
Yes.
Excellent. So thank you for sharing these excellent awards as case studies. Do you want to get into any of the nuts and bolts that might help people understand what you're doing when you come into a new organization?
Yes, maybe I could start talking about that. And Danielle, maybe you could bring up the slide with the Tray app or whatever, so I can explain how we're um, you know, the methodology and the install process, which is usually arduous and takes, you know, months to do. Um, oh, I love that inch by inch, life a cinch, yard by yard, life is hard. Yep. I used to call that principle inch pebbles, you know, when I at my last company. It's like we're just trying to get that much closer today towards perfect. We're not going to get there, but we can get that much closer, maybe. So you know, easy is not just our, you know, facile means easy in Spanish and French, I believe. It's a way of life for us. So um our we get this a lot of like the IT involvement and stuff. There's no IT involvement because if you can download the Zoom plugin, you can download our agent. It runs in the tray. You can kind of see it there. We actually named it the iBip service in honor of Kenny, if better is possible. So it's actually the iBip service. It's not the, oh, here he is. Here's Kenny,
Please
everyone.
join.
Yeah.
What am I walking into?
We're going to talk about
Hello, Kenny. Mike Bordenaro. I'm the Executive Director of the Asset Leadership Network. And what we do is try to help leaders understand current tools and processes that they might not even know were possible. And we like to highlight our member organizations and the work that they do for the asset owners. And they've talked quite a bit about your working smarter, not harder approach, and how happy they are for winning awards for working with you.
Yeah,
And
I don't work hard at all.
yeah, you see him kick back, like leaning back, laid back.
I wish so.
Yeah. Actually, it does work pretty hard. So but working
so
smarter.
did you know you were getting into just a whole leadership perspective, or you're just trying to solve your problem and your relationship with Keith brought you to this innovation? How did it work?
My relationship with Keith brought me to this innovation, but as far as the leadership thing, I mean, my personality is I've been the lead follower, get out of the way guy for a long time, and I'm not real good at following people because people are too slow, you know. And so I've been a leader since I was, you know, 20 years old or less, right? I believe that my religion or karma or whatever you want to call it, my charitable contribution to the world is that we shouldn't all be reinventing the wheel. And so when I find things that work, I try and share them with people, right? You know, and I've been doing pilot startup R&D for a long time, right? Keith wasn't my first rodeo, although he's become the most notoriety one, I probably you know would say.
Yeah, Kenny's story is kind of like above him right over there. It's like the kind of the ode to Kenny. You know, he started off at, you know, and I don't want to talk for him, but I mean, several startups, but the Limo Smart Energy Valves, Danielle mentioned that, Sky Spark, Enlighted, like he was a huge one of the first Enlighted campuses. So there's been we're like the sixth or seventh company that has kind of been, you know, incubated. I mean, literally, we were part of the Cal State Dominguez Hills incubator 5 years ago. So they gave us.
Oh, okay.
And then, Kenny's been gracious enough to allow me to share his conference room here above the central plant.
Take over.
So I'm not taking, we actually do have a physical office in Gardena. Like my wife was like, why are you paying all that money? You're never there. And I'm like, yeah, no, we just needed to hang our shingle on. But I just love hanging out with customers and just learning together and making it better. Like I'm immersed myself into this stuff literally.
Yeah, for me, it was his background was aligned with the campus, right? He was an old JCI tech. Once I vetted all his BS and found out that it was true, I'm like, wow, well, I can't lose by being friends with this guy, right? Because at a very minimum, I was already trying to do innovative stuff with my building automation system, but I was limited to, you don't know what you don't know. And then, the people that work for me and stuff. And I'm like, well, if we have a problem, we just Keith, what's this Wireshark thing? My stuff's not communicating. Can we do this? And can we do that? And so I was selfish in the beginning, right? Because I thought, I'm going to get something out of this. And yet then as it started growing, right, this is who I am, right? Solving problems and fixing things. And so he'd be talking about his stuff and I'm like, oh, well, what if you did this? What if we do this? And it's like, I've got the common sense logic side of things on how the machines run together. And this guy can sit down in 5 minutes, write a code that says, oh, let's do this. And here's the outcome, So it just became a really fun friendship, partnership, an
award-winning partnership.
Award-winning partnership, yeah.
So you were not afraid to lead the way into using AI. What would you say to other large owners about what you've done, how they might get started? What would they look into?
I mean, I would say they should use Keith, but let's say they don't want to use Keith, right? Let's say they're going to use somebody else. There are a couple things that make it really, really safe. And I don't think people understand that, right? They have these fast talking salespeople that are like, oh, we can do this and this and this. The first thing I would say is ask them to show you real world data, right? But let's say that they can come up with that. All right. If you create the guardrails, the limits, right? This is the minimum I ever want this thing to either run my pump or set my temperature or how many chillers to run. And this is the maximum that I want. Then the reality of it is if you trust the person you're working with, then you can't break anything. Right. So if I say, and that's what we did, right? We said, look, we never want to get below 60 or above 90 degrees on the condensing water temperature set point, right? So what if Facil screws up and decides to run at 90 degrees? What's really the worst that's going to happen? That's the range that my chiller could run. And so it's just going to run inefficient. And so before I met Keith, we were doing 5 degrees above wet bulb. But before that, when the chillers went in brand new, I didn't know what I didn't know. And I was told by somebody that cooling tower fan horsepower is much less than compressor horsepower. So why even care about controlling the speed of the fans? Just run them as fast as they'll go, decrease as much temperature as you can.
Make the chiller happy.
And the chiller will be happy. Okay, and I ran like that for 3 months before an engineer that I was friends with said, Ken, there's this thing called physics, and I don't care how fast you run the fan, you're not going to get below 5 degrees above wet bulb. Right? And I'm like, well, oh shit, then why am I running these things like this? He's, I don't know. I didn't tell you to do that, And so we went to 5 degrees because, and he said, 5, 6, 7 degrees, but you'll never get below 5. I'm like, oh, well, I'm aggressive. I want 5. So that's what we're going to run.
And that's the floor. And then if you don't mind, Ken, I want to interject.
That's fine.
So because we have all these decades of experience, like I have decades in central plants, like literally for almost 40 years, some of the most advanced central plants in the world, $1 million a minute loss at the Bank of America data center back in the 80s. Like you talk about mission critical. that's the most mission critical you could get other than a hospital. But yeah, I mean, 0.7 kW per ton, that's where you're at. You can't you can't get closer than 5 degrees to wet bulb, outside your wet bulb. So why would you ever try to run 7, 8, 9, 10, 12 degrees above it? Like, that doesn't make sense. You're going in the wrong direction. Really? So we put this 7-degree thing because we're biased humans. We're all our decades of knowledge is working against us. And the AI, the more higher we raise the ceiling, it was bumping up against it. Like, it's like a horse ready to, get out. And so we just turned it loose. I said, Ken, why don't we just take the upper limit out of there? Like, just see where this thing is gonna go. And so honestly, we're running everywhere between 4 degrees above wet bulb. We've seen it as high as, maybe 20.
Yeah.
15, 20 degrees. Who would have thought? Who would have thought that?
And the
So-
nation, like, you can't do that, because the OEM says this is the best it's gonna run. I'm like, okay, well, the OEM for, Ford Mustang says this is what it's designed for too. It doesn't stop people from tweaking it to
Yeah.
get more horsepower
The
and stuff out of
supercharger on
it,
it or turbo, yeah.
And so, and then the other concept is, like, we have people, naysayers about the KW per ton and stuff. ASHRAE 90.1 says the best you could run a chiller is 0.45 kW per ton at the chiller. And who cares what the chiller is? It has to be the whole plant, because it's the cost of making chill water. It's not the cost of just the chiller to run, And so there's a lot of preconceived. Keith taught me the word bias. I mean, I knew bias, but I use it all the time now, right? There's a lot of preconceived biases that people have because that's how we've always done it,
So that's the asset leadership aspect of this. We're not the asset management network. We understand that the tools and processes now allow top decision makers to have information in ways that they did not have before. And then that changes everything else underneath it. So things like just the fear of AI, how did you overcome the bias against AI?
Yeah, again, it came down to risk versus reward, right? And I didn't see a risk in it. Once you understand it, right? Once you stop thinking of it as this black box Chat GPT magic that just goes out and Terminator 1, 2, 3, 4, 5, right?
Right.
It's like, look, what is it doing, right? It's at the end of the day, it's a program. I've been running a program since 2011, since I got here, that says, wet bulb plus 5 degrees or whatever, that's a program that somebody said, hey, this is how you should run it to be efficient. In my mind, there was no difference between the AI, because as long as, again, I was from the beginning, where are my safeguards, right? That was the thing, right? And people inherently don't think of that. They just think, oh, AI is they're gonna put this black box and talk to my system. And what if it tells it to do the wrong thing? Well, then shame on you, because you didn't build in safeguards. But if you build in the safeguards, we have a heartbeat monitor that I helped Keith design, right? That was because the AI guys are going to tell you, you don't need that. My stuff is good and it's safe, right? Yeah. But the leaders are like, who the hell are you? To tell me, right? Yeah. We hear all the stories. 90% of them probably are stories, but we hear that, and so. Yeah. All right, well, let's just do some simple things,
And I've actually got it up on the screen, by the way, Ken. So you can see it's 12:44. In less than 1 minute, it's going to calculate a new solution. But yeah, you see where we're driving. We're 933 tons. It's creeping. The plant efficiency is 0.62. We're nearly loaded up, but we're only using 586 kW. So that chiller still, it's only, what is it, 68% loaded up, and there's a solution running. So it gathers the point data for the central plant and makes sure that everything's operational, everything's in line, no faulty sensors. It calculates a new solution, got the master enabled switch, or kill switch enabled. I'm going to perform an adjustment based on this new solution. You can see that solution number 2717. So it's like, Facil, Why did you change the set point to 82.738 degrees? Well, almost a month ago on June 1st at 11:34 p.m. or a.m. That's what it was. At that time, the plant efficiency was 0.63. We're at whatever, 0.66. So I think we can get better than that. And it does that every 5 minutes. It takes it 5 seconds. We're not doing all this. You hear some AI people, they're talking about we got this forward propagation and we're going a year from now, and then we're going a year back, and we're calculating all this. We're transporting through time, and then we're going to come back at 5 minutes, like the second after the decision. We're not doing any of that. We're just calculating the next 5 minutes. What does the next 5 minutes look like? That's the time horizon of our AI. It doesn't care about anything outside of that. It uses everything before that, but we're just looking 5 minutes at a time. It's like driving down a road. It's inference training. It's not training compute. It's inference computing. It's like autonomous drone flying through a forest always.
Well, it's like cruise control. You need more gas going up the hill
you're
than
going
you
up
do
the hill,
going
you're
level.
going
So you
down.
can't have the same setting
Man,
for
I don't
everything.
care. I don't care
No.
about the future. I just care about what's in front of me and keeping my eyes on the road.
But going back a little bit to the fear factor, like I said, the biggest thing was just do something smart that protects you, you know. Keith said, you know, the master kills enable active, right? We put a kill switch in so that if my operator saw something not to what they expected, whether they understood it or not, it gave them that knowing control that, look, I can push this button. And the way that we programmed it was, if it doesn't see a heartbeat every 5 minutes, or my operator hits the kill switch, the system just goes back and reverts back to the old 5 degrees above wet bulb. We're 7 now, but you know, and so nothing changes. We're not doing an override on the system.
Yeah.
We're the set point is a set point, and it's either facil writes to that set point or my old program writes to that set point. And so we separated. We have a level of separation there between the AI and us, right? That we have control of, and that we control based off of if the internet goes down or the cloud or whatever, we don't get stuck at some crazy number because that's where it was, you know, an hour ago. And so that, and then just the payment structure is like, look, you know, we'll put it in for a month or two, and if you don't see the savings, we'll walk away, you know, because your system is super smart. And you know, you're right, because there are people that can run really good, you know, but they're adjusting it all the time. And that's the beauty of the AI, is like, it doesn't care what time it is or what day it is or what the weather is, you know, it's going to look at the factors in that 5 minute window and say, this is how we should be running efficiently. I can't do that. You know, I set it for 7 degrees above wet bulb, and that's where it's going to run 24/7, whether it's running at 1,000 tons or whether it's running at 50 tons.
Yeah.
And
right.
so,
yeah, right now we're flying 18 degrees above set point or something like that. Yeah, 18 degrees.
Okay, Kenny, it sounds like you've got quite a bit of autonomy in being able to make decisions related to the plant.
yeah, I'm the chief engineer, right? I mean, I'm the director of central plant operations, but at a micro level, my office, we're in the central plant. I'm in charge of 9 guys that are in charge of all the heating and cooling for this campus. And
How many square feet for your campus?
1.5 million
Of square feet of building space?
of building space. Yeah, I don't, the acreage is a lot more than that, right?
Yeah.
So,
All right, so you didn't really need any approvals, but what are your leaders saying about this?
these are my meters.
No, leaders.
Oh, leaders. Oh, there's when I brought the trophy home that says I beat Stanford, that's right. That's a drop the mic moment, you know. But I was given the nickname Kennergy 5 years ago, right before COVID, because I had already saved $1 million in the utility budget. Right. So I had worked, like, you know, that's why I said my life's easy. I just kick back. No, I've worked really hard at creating a reputation and a level of success, right? You know, little successes grow into big successes, right? You know, I've never had to ask for money from my cabinet, right? I've found my own money, whether that's grants or rebates or being in the right place at the right time, which takes work, you know. And so you gotta, you know, they say you have to have a champion, right? You know, to make these things happen. But
Yeah.
but more than that, you also have to be a successful champion, right? You can't just sit back and wait for things to happen. I go to conferences and tell people, how do you get shit done? You don't wait for somebody to give you $400,000 to put meters on your campus. You wait until you got $1,000 left over at the end of the month on your credit card, and you call your buddy up and say, hey, send me an Eamon Demon meter and just charge the card today, right now. I don't care when it shows up. And then you get 4 of those, and then okay, let's go install these, you know. It's like, you know,
Innovative approach there. Yep.
yeah, the little wins come out to be the big wins, you know, and the more successes you have, the more autonomy you get, right? And so once you build that level of trust, you know, and it's not to say I don't screw up. I did a project that was like $1 million project that was gonna be life change. It was gonna change the way we look at HVAC. And it was a huge failure. The guy went bankrupt. He didn't pay the bills. I ended up getting called on the chancellor's office, you know, doorstep, blah, 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 blah. And I'm like, look, you know what? Even Hank Aaron had to have struck out once, right? Yeah. And so, you know, my hand got slapped and I kept on going, and, you know, that was before facil. And so, I think that's what it kind of is.
Yeah, I want to interject for some of the control nerds out there. So we get a lot of apprehension about how aggressive the AI is working. And who's to say that that's not the right way to run the building, right? Run the controls. So you can see, for example, we were just 80 at 82.7 degrees set point, and now we're all the way back down to 75 degrees. And people start freaking out because in our system, I think we're kind of seeing that, Ken. We kind of attenuated it so it couldn't make that big of a change. But I kind of am changing my mind about this. Like, who's to say that this is not the way? I just got a new car, it's a Mercedes SUV. This thing is like an engineering marvel. So it's got this auto park feature. This thing is huge, and it can actually back into a parking stall. So it was scary the first time I tried it. He's like the owner of it. He was like, okay, Keith, pull up next to this car. Okay, and take your hands off the wheel. And we're so scared. And I'm telling you, we're used to like slow and steady turning the wheel. This thing rolled backward, and at the moment of inflection, the wheel, it was like this, like it made 3 revolutions in like half a second. It's, ooh, whoa, you know, that wheel's like, it wasn't the AI driving that car was not scared about breaking the steering wheel by turning it too fast. Like it was so precise, and it parked that huge SUV like precisely. It just went whoop, and it just went right into the stall, didn't hit anything. And I was this fearful human, like underestimating the power and the precision of AI. And I think we gotta there's something to be taken from that. Like I said, I'm a huge car guy.
That's a good point.
Think like we really like take the hands off the wheel and let the AI do what it can do best.
Excellent. Danielle, can you share some insights on how working with Kenny and the success of this is going to help with getting the message to other asset owners to be able to move forward with this? Because as Keith just said, it's kind of scary.
I mean, the fact that Kenny is willing to advocate for us says worlds about our product. I don't know of a whole lot of other marketing teams in our industry that can parade around a customer who is willing to talk about the product without being paid, without anything being organized. I mean, Kenny just walked in the room and did an impromptu talk about how great our product is. And I see that as a huge asset to us. It's a huge benefit to us. But it's also a huge benefit to other people who are trying to learn, because it's not secret information. This isn't a competitive advantage. This is us coming together as a community to say, look, this is a product that can make a difference for your campus, for your portfolio, for your planet.
Yes, thank you for that, because one of the things the Asset Leadership Network tries to do is rapid deployment of best practices. And Kenny, you got some best practices going on here, and it seems like you also want to do the rapid deployment, that helping others is part of your mission. You're at an educational institution. It only makes sense that you're doing that.
Yes.
And we look forward to doing more of these types of programs to get the word out to even more people. And one of the things we like to do is connect with other associations. Campus Facility Management Technology Association, and others through our partner Numa and CDV Systems and others. We hope to be doing things as network to get this out there. The organizations around the world need this level of savings. And if we want a chance, we got to get this out quickly. That's the rapid deployment part. So
Yeah. Yep.
yeah. I'll let you each have a chance to say final words and then wrap up. Keith, you want to go first?
Yeah, sure. So I mean, we're only scratching the surface of what we're going to do. So we've got 2 agents right now deployed and in production. We have a rooftop unit at scale, saving one of our retail customers, 1,800 stores, 6,000 zones, 6,000 RTUs, saving them $250,000 a month. Kenny's running our chiller agent, and he's saving $250,000 a year. So very impactful, increased production savings too. We're working on an air handler, airside agent for air handling units, zones, heat pumps. I mean, Kenny mentioned his heat pump, air to air, air to water heat pumps. Working on a lot of different agents out there. Going to start dipping our toe. Don't want to be premature, but we're going to start dipping our toe into fault prediction, not just fault detection, but fault prediction and analysis. Stay tuned for that. So yeah, we're going to start covering, I think, the other 20% of the equation now, because we just get, we didn't plan on, we plan on staying on the optimization side, but we just always get pulled into the fault detection. We're getting confused with it. So yeah, I'm very excited about for what's coming for us in the future.
Excellent. Danielle, we'll let you go next, and then Kenny can have the final word.
Sure. I think to just wrap it up, I mean, as far as asset leadership goes, it's really, like Kenny said, it's about weighing risk against reward. And generative AI and some of the new AI things seem very risky. We're not playing with the new risky AI. This is tried and true. The AI technology we're using is 20 years old. It is safe. There is very little risk. And the reward is, I mean, other people think it's impossible. So it's I think it's an easy decision.
Yeah, that's a great point, Danielle. So we actually got humbled by a conversation that our VP of AI had with ChatGPT. We think we're high flying with our fancy new technology. Our particular branch of AI is called Iterative Learning Control Frequency Domain, so ILC-FD. And it's like, you know, we're so model predictive control, or MPC, is 50 years old. It's like, man, Facil, you're doing a great job, but yeah, you're only 20 years old. Your technology is only 20 years old. So this is not bleeding edge, you know, cutting edge stuff. This is proven, tried and true technology that's been used in other mission critical fields, everything from space flight to hospitals, medical, surgeries, like all kind of stuff. So it's the reality is just taking us a long time in this category to catch up.
And Kenny, thank you for joining us. Would you like to make any closing remarks?
Yeah, I would love to. My motto is, if better is possible, good is not enough, right? So when I see things that can increase the efficiency, I'm okay with a 2% increase, right? You know, and when they're bigger, that's great, but it's all about making those, you know, small percentile increases. Just one last story. So when we, in the beginning, Facil was running, it was running for the winter time. We were hitting just unbelievable numbers. We had naysayers telling us, yeah, that's great, but what happens when you're really under load in the summer? And my response was, who cares, right? Because if I can get we were doing almost 50% energy increase during the winter time. do you really think it's going to be worse in the summer? Right? And so if I can kill it 9 months out of the year, but I break even the other, 3 months, then that's a huge win. And the
Yeah.
reality of it is we found out, and when I finally got the summer numbers, it was like, we're still killing it, right? It was a huge increase. And so again, that, and just looking at, the risk versus reward, what was the worst that could happen? My chillers shut down all the time all by themselves because of safeties and limits and, different stuff. And so what's Facil going to do, right? Puts it, at the limit. I didn't have guardrails before. Now I have all these guardrails and stuff. So I'm even safer now than I was before.
Yep.
So
That's excellent.
Yeah, just to drop the mic moment, like, what are we doing during the summer? Well, it's June 26th, and you can see up there on the screen, we're 80.5 degrees, and we're putting out 923 tons on a 1,000-ton chiller using half the energy. So it's at 485 kW. Here's the virtual mic. Like, I'm just going to end with that.
agree.
Okay. So that concludes that. We want to thank all of you for participating, Kenny, especially for just, walking in, and thank the audience for their attendance. Now, next week, it's July 3rd. So we're not going to have a program, but we're going to start up again on July 10th. And we got Sue from Canada. She's a fascinating woman who has incredible experience with asset management in mining and all types of situations. And then on the 17th, we've got 2 ALN senior fellows who are going to be talking, having a dialogue about why owners should move into asset management or expand their asset management. People still are not as bought in as Kenny is with these incremental improvements. And so they're going to be talking about some of the typical hesitancies and how to overcome them. And we wish everyone in the US a very happy 4th of July next week. And we'll see you again on the 10th of July. Bye for now.
Thank
Thanks,
you.
everyone.
Appreciate it.